Next problem, solve d power 4 minus 2d cube plus 2d square minus 2d plus 1 into y is equal to 0. We have to find the solution. So, first of all, write the auxiliary equation. The auxiliary equation is m power 4 minus 2m cube plus 2m square minus 2m plus 1 is equal to 0. Okay, just replace the operator d with m. So this is the auxiliary equation. We have to find the roots of this equation. Since it is a biquadratic equation, the degree of this equation is 4. So this equation has 4 roots. We have to find that. So let us see this sum of coefficients. Sum of coefficients, that means coefficient of m power 4 it is 1, coefficient of m cube it is minus 2, coefficient of m square it is plus 2, coefficient of m it is minus 2 and constant. Okay, say this minus 2 plus 2 cancel, 1 plus 1 2, 2 minus 2 means 0. If sum of coefficients is 0, then m is equal to 1 is a root. Okay, this is the concept. If sum of coefficients is 0 for any equation, then m is equal to 1 is a root. Okay, so using this root, and we have to apply the Horner synthetic division method for this equation. We can find the other roots also. So let us see that Horner's synthetic division method. Horner's synthetic division method. So in this method, we can write the coefficients of this equation like this: coefficient of m power 4, coefficient of m cube, coefficient of m square, coefficient of m and constant. Okay, so using this root, we have to divide the equation like this. So first keep 0 here, add these two numbers, 1 plus 0 1. Now multiply these two and then write here 1 into 1 1 1, minus 2 plus 1, add these two numbers, minus 2 plus 1 gives minus 1, and multiply these two and write here 1 into minus 1 minus 1. So 2 minus 1 means plus 1, 1 into 1 1, right here minus 2 plus 1 minus 1, 1 into minus 1 minus 1. Okay, so this is called remainder, it is 0. Okay, now this is our quotient. Okay, so this is equal to constant, coefficient of m term, coefficient of m square term, coefficient of m cube term. Okay, therefore the quotient is like this. So this is m cube coefficient, this is m square coefficient, this is coefficient of m, and this is constant. So m cube minus m square plus m minus 1 is equal to 0. Okay, so again sum of coefficients we have to check. Again we have to check sum of coefficients. The coefficients are 1 minus 1 plus 1 minus 1. Plus 1 minus 1 cancel, plus 1 minus 1 cancel. Again we get 0. That means again m is equal to 1 is a root of this equation. Okay, therefore again m is equal to 1 is a root. That means 1 is the multiple root or a repeated root. Okay, so again we have to apply the Horner synthetic division method for this equation. So 1 minus 1 plus 1 minus 1. Okay, so m is equal to 1, keep 0 here, that is the procedure. 1 plus 0 is equal to 1, 1 into 1 1, minus 1 plus 1 0, 1 into 0 0 right here, 1 plus 0 1, 1 into 1 1, minus 1 plus 1 0. Okay. So this is the remainder and this is the new quotient. Okay. So this is constant, this is the coefficient of m square. Therefore, the new quotient is like this m square plus 1. This is constant, this is coefficient of m, that means there is no m term, coefficient of m square, that means m square plus 1 is equal to 0. Okay. So m square, transposing 1 to right side, it becomes minus 1. So eliminating square, we get like this, plus or minus root of minus 1. So plus or minus root of minus 1 means it is nothing but I, imaginary root. Okay. Since we have like this, I is equal to root of minus 1. Okay. Finally, we have the roots for m like this, 1 comma 1 I comma minus I, or plus or minus I. Okay. So these two roots are real and equal and these are imaginary numbers. So the solution for this equation can be represented like this. So these two are real and equal, so that we can write like this, c1 plus c2x into e power x. Okay. So these are imaginary roots and there is no real part. Only imaginary part is there. So that we can write like this, so c3 cos x plus c4 sin x. Okay. So finally, this is the solution. Thank you.